Today's webinar is Curbside Pickup in less than 6 weeks. We're going to share with you some of the pros and cons of microservices and monolithic solutions as it relates to curbside pickup. We're also going to talk about a real-world example of enterprise-level curbside architecture and how we used AWS Lambda to allow for a more scalable solution. Lastly, we'll share with you 6 best practices you should be sure to follow when developing your curbside application. Our presenter today is Joe Rose. Joe joined JBS more than 8 years ago as a senior developer and is now our Senior Vice President of Delivery. Joe has over 14 years of project delivery experience across many industries, and he's worked from startups to established enterprise systems. His pragmatic technical expertise delivers on projects. He delivers projects on time and on budget with a level of quality and craftsmanship that our clients deserve. Let me unmute Joe. Joe, you there?
Yeah, I'm here. I was going to say we're going to be off to a great start if you mute the presenter and he can't unmute himself before we get going.
Well, Joe, on to you. I'll be quiet now and let you talk.
All right, I pinned my video so that you can watch me wave my hands in the air. Does everyone still see the slides okay?
Seem fine.
All right, great. So overall, we want to talk about some best practices and some architectures and how to deploy things in a modern way with a specific use case of curbside pickup. So we're going to talk about how to select the right architecture, how to implement that with a hybrid approach, and then actually really dive in on a specific implementation in architecture so that we can see how it was built and then go into some things we've learned along the way. So first of all, let's start off with what some of the challenges are when you have a monolithic system. So when I think of a monolithic system, you're a retailer. You have an old POS system that ships flat files around for accounting. You have an e-com system. It's off the shelf, say it's WebSphere Commerce Server, or it's a Demandware. It's a purchase product that you customize with code. You've got an order management system. So maybe you've got IBM Sterling, or maybe Nav is in there. And the way all these systems interact is you get a user who does something on the website and the e-com system. It generates a file or makes a SOAP call or goes through some enterprise bus like a TIBCO or a Fusion and sends data to the order management system, which sends it to the warehouse system, and then in turn sends it over to the accounting systems for reconciliation. So it's all, think of it like a pipeline or an assembly line. All the data just goes from right to left, just kind of goes from one system to the next to the next. And it's all been done on, kind of an old 10-year-old or 20-year-old pattern of, it's not quite as bad as it used to be. We're not just doing straight point-to-point integrations. So we do have some concept of a central bus, but it's still not an agile system. So you're going to start to see some problems with that if you want to start to do things rapidly. Like, oh no, we had to close our retail storefront and we can't have people walk into the store for buy online, pick up in store anymore. We need to make it curbside. So how do we do that quickly? So these are some of the challenges that we'd expect you'd run into with this type of architecture. So one is when you think of that pipeline of, on your left, you've got your e-commerce system, and then your order management system, your warehouse management system, your accounting system, and data kind of flows from left to right. When you say, I want to implement curbside pickup, when you solve that problem, you have to think about all of those systems together. Each of those systems implement a piece of that, but they're all glued and connected together. So you can't just carve off a piece on the side and say, I'm only responsible for X. What does this small thing have to do? You have to think about the whole solution. So you're going to hear your enterprise architect or your enterprise architects all sit in a room and debate how to get information from the front of the system all the way to the end to support this. And we got it all the way down except into accounting, and we don't know how to get it from accounting up into EDW. So we have to go back to the beginning and start the whole flow over and try to figure out what it is. So taking something, a feature set, and composing it into a series of technical tasks and a project plan that can actually be implemented is a lot tougher when it is a string of monoliths glued together, kind of that traditional enterprise architecture type of design. So deploys can be painful. You can't just snap your fingers and say, okay, the middle piece of the chain is ready, so they're going to go ahead and deploy, because when they do that, usually they break their integration with the system that comes before them and the system that comes after them. So usually the way this works is you've got a Gantt chart where everybody says their individual piece of development is done and it's all connected together. And now we're ready for the big bang deploy. We're going to do a system maintenance, and the whole thing is going to go out at once, and we're going to bring it all back up online at once and hope it goes well. Because if it doesn't go well, we're going to have a heck of a time rolling it back. It's really easy to introduce regressions, is when these systems are that massive. Think about how many features an e-commerce system has. It has the cart promotions, tax, product recommendations, order history, personalization, and on and on and on and on and on. And anytime you touch anything in that system, you're tugging on a thread and you're hoping that it doesn't unravel something somewhere else. Multiply that times the number of monolithic systems that are bolted together, and especially something as aggressive as we need it in 2 weeks. And you're not leaving a whole lot of time to test the whole thing end to end. So it's really easy to introduce regressions under that type of architecture, and that can really slow down your ability to get stuff out the door. It can be tough to scale up or down, and from that I mean a performance perspective. The challenge that a lot of people have had from an underlying infrastructure perspective in COVID world has been, some things are getting a heck of a lot more traffic, 10 times or 100 times more traffic than they used to, and some things are having almost no traffic. So the in-store returns system, not getting a whole lot of traffic. Curbside pickup, massive amounts of traffic. And if you have this monolithic architecture, typically I've got 10 e-commerce application servers, and they're deployed here, and it's server 1, server 2, server 3. And if you have a spike in traffic, it's not like you can just go buy 10 more servers off the shelf and throw them in the rack and then hope that you have that in time. And then when that traffic dies down, you're still paying for that infrastructure. It's still there. Now, obviously, there are more modern things that can help with that, Docker and containerization and stuff like that. But those off-the-shelf monoliths don't tend to play well with those newer type of deployment methodologies. So Demandware, or especially if you're on an older version, Demandware or a WebSphere Commerce Server or something similar like that, usually does not play well with Docker. So you don't have an easy way to scale up and scale down. It can be painful to change frameworks or introduce a new technology. Why would that be important? Well, you want to do new things. You want to implement curbside pickup. So you want maps integration or arrival time integration, or these new pieces of functionality that are being released into the industry as open source frameworks or SDKs that you can buy. If you're on an older system and it's really, really painful to upgrade it, you're not going to be able to leverage those things. So you're going to be stuck well behind. And then you have the architecture that shifts and fractures over time. So think of that big cobbled together, glued together system, from left to right, this big long pipeline. As you keep jamming more stuff into it, hey, it needs to be done quick. So maybe the customer reference 2 field, maybe we just use that. And we have customer reference 3 and 4. So if we need 2 more fields, we'll be able to jam them through, and then you run out of fields and then you don't know what to do. Or come to find out that some system upstream uses customer reference 2 for something else. I mean, those are the kind of problems you run into when you take something that is that big of an architecture, that complicated of an architecture, and you design it. There's no way you're going to be able to anticipate every possible thing that may come up. So when you need to migrate that architecture to support more feature set and functionality, it's almost impossible to do. You usually have to compromise the architecture pretty heavily to accommodate change. So there is a solution. It's a buzzword. I'm sure you guys have all heard it. It's a way out, a light at the end of the tunnel, and that's microservices. It's a way to develop large-scale enterprise systems that lets you deploy quickly, jam out feature set and functionality, deal with scaling, decouple teams, and I don't want to say it's a panacea or a cure-all, but it really does make a big difference. So let's talk a little bit about what microservices are. They're essentially finite, cohesive, loosely coupled components represented as services that represent a set of functionality that drives an enterprise domain. So if you take an e-commerce domain that has curbside pickup, for instance, these might be the services that comprise that: a mobile app service, a location service, an in-store app service for dealing with employees, an order management service, an in-store paging service of telling employees something needs to be picked up and brought outside. So instead of being one monolithic e-commerce platform and one order management system, it's actually a series of services that have finite, concrete responsibilities. They can focus on their one thing and do it well, and implement the same end result, but just much more efficient. So this is what it would look like from an architectural perspective. Each of these different services are deployed independently. They are fronted by an API gateway. Think of that like a traffic cop, telling people where to go for certain services and what APIs can or can't be accessed and what those payloads are. And that client essentially is transparent or is not aware of what each of those different services are because of that API gateway. So it handles a lot of the complexity of routing you to the proper service for the proper thing. And then you also have your CDN for static content and your identity provider. Those are kind of things that always kind of sit off to the side. How do you get HTML and JavaScript and CSS to a user, and then how do you know who they are? So the benefits, they're essentially, when we go over the benefits of what microservices are, they're going to be the kind of the opposite of what the downsides of monoliths are. But we'll get into that more concretely. So removes dependencies and allows for faster development. When you looked at that previous architecture, one of the things you noticed was that all the services were horizontally stacked. It wasn't a big line from left to right. They were horizontally stacked. And by that, you have your product service or you have your user service. You can change it, you can update a new version, you can release it, deploy it, whatever. Not a whole lot of things are depending upon it. And whatever needs to change on the front to get it to talk to the back on that long, big pipe, that obviously requires a ton of synchronization and coordination. On the microservices front, you don't need that. As long as you're deploying something that's backwards compatible, you can deploy as often as you want. And you're not breaking anything. None of the old stuff is going to stop working. So you don't have dependencies or coupling. The deployments are easier and automated. And I kind of go back to what I said about the off-the-shelf e-commerce platforms that don't support Docker well. The reason why they don't support Docker well is because they're massive. They're hundreds of thousands or millions of lines of code and all these different components and services and pieces. And microservices just in general, they're smaller, they're tinier. So it's easier to take a microservice and bundle it up into a Docker container or a Lambda function and deploy it. Reduces the coupling and blocking between teams and is easier to maintain. So we talked about it mostly to this point from a technical perspective of the e-commerce system ships a file to the order management system, ships a file, or so on, or Fusion payload. So that's true. When you're making everything API-based and all the APIs are backwards compatible, the coupling or blocking between the services themselves is greatly reduced, but it also reduces the blocking between teams. And I can't stress that enough. Under the traditional enterprise architect, left to right architecture, the e-commerce system needs to know what's happening all the way down to the warehouse management system and all the way down to the enterprise data warehouse. The amount of things they have to keep in their head and people they have to coordinate with to build their system in a way where it functions, it's crazy. It's a massive amount of coordination that has to take place. Whereas if I know, as long as I'm backwards compatible, I can do whatever I want. One team has asked me for a new piece of functionality. I'm going to release a new version of the API that does that one thing. That's all I have to think about. Just my piece and my one piece of functionality that I'm going to release in the API. I don't have to worry about anything else. So it significantly reduces the coupling between teams. And that's kind of the understated thing with microservices. Everybody thinks of it as this is a purely technical benefit. I'm going to have some really cool architectures and be able to go up and say, oh, look how awesome I am. I'm scaling with API gateway and containers and Lambda and such. But there's a massive organizational benefit to implementing your teams in this pattern. You get more cohesive architecture, and that's just because it's smaller. It's easier to architect something that is smaller, therefore it becomes a more cohesive architecture. And then the scaling is also very easy. Because we can use things like containers and because we can use really awesome technology like Lambda, the scaling is very easy to do versus scaling up and down a monolith. And the scaling is actually per component. So if the add to cart service is the one that's seeing a lot of load, we don't have to scale up the whole e-commerce system just for the sake of add to cart. We can just scale up the add to cart service. It allows you to build things in different languages and have tools that are different per microservice. So something like a live chat where you have a lot of concurrent connections and you're using WebSockets, maybe Node.js and JavaScript is a great choice for that. If you have something that's product recommendations and you're doing some ML or something like that, maybe Python's a great service for that. Because everything is driven by APIs, and most programming languages, or all of them really, modern ones anyway, support making RESTful calls over HTTP. You can use whatever technology you want per microservice. The only star or caveat that I would say to that is if you're a CIO at a company, each language that you introduce is a competency that you have to hire for. So if you have a Python, a .NET, a JavaScript service, say those 3 services, you're probably going to need 2 or 3 people who can program those languages at a minimum. And if you're large enough that doesn't scare you, press ahead full steam. If you're a smaller company, that can be tough. You might say, well, I only have 4 developers total. And now you're telling me I need to make sure I have 1 Python, 1 C#, 1 JavaScript. So although the technology itself allows you to use as many languages as you want, there's organizational reasons why you may not want to do that. All right, and then the last one is the faster introduction of new features and technology. And that's what I alluded to earlier about there's either new paid for SDKs that are a lot of functionality that you can implement quickly because you're dealing with a small microservice, or there's new stuff in the open source world all the time. Feature set and functionality that you go, oh, wow, that would serve a need, or that's a cool piece of tech that we would love to pull in. And if you're in a microservice world, it's a lot easier to pull that type of stuff in. So the independent teams, to kind of recap that, think of your e-com team and your e-com system. You might have 40 developers that are on that team. So imagine what a stand-up with 40 developers looks like. And you can try to say, oh, okay, well, you don't have to have 40 people in one team, Joe. You could just do 4 teams of 10. They're still deploying the same thing. So they all have to have their code freeze, which you should never hear in a microservices world, but they all have to have their code freeze at the same time. They have to have their deploys out to QA at the same time. Their production deploy is all at the same time. So if you have that many people doing the same thing at the same time, usually they have a lot of the same meetings. What's the deploy release train meeting look like? And if they're independent, you don't have that. And then of course, smaller is faster, independent's faster, simpler is faster. Knowing that all I have to think about in my head is the cart service and nothing else makes me faster versus the entire tapestry that is an e-commerce system, and I'm tugging on a thread wondering what's going to break. So that's an important one to call out in terms of the benefits of this. So one of my favorite expressions is there ain't no such thing as a free lunch. If you get that reference, kudos to you. And it's true. When you implement this pattern, it's not all good. There are bad things that come with it. There are problems that you have to solve. There are complexities that get introduced. So if you have all these services all over the place, you went from one microservice or one monolith, ecommerce.com, and now it's 7 different services. How do I find them? Where do I know where they are? How do you have fault tolerance? One of my 7 services is down. What do I do now? Versus, well, ecom is down. The whole thing's down. It's either up or down. You have to maintain backwards compatibility. So one of the nice things, if you want to call it that, of having that large enterprise architecture coordinated deploy pattern is if you know you're going to do that and you're all going to deploy at once, you don't care about backwards compatibility. Rip it up and break as much stuff as you want. Everybody's going to deploy at exactly the same time. And hypothetically, if you do it right and you're lucky, it will work. Whereas under this pattern, you have to maintain backwards compatibility. And you have to keep maybe 3 or 4 versions alive before everyone moves to newer stuff and you can kill all the stuff. So you can have some older versions of the API sitting around that can be painful. And then it's a tougher mental model. It's easy to look at some code and say, okay, the add to cart code called the user code. And I just put a debug statement on that code and trigger a breakpoint and figure out where my bug is. Whereas if it's 7 different services, 7 different code bases, and There's network calls flying around. They may go out of order. There may be a bug where you fire off 2 requests at once. And if A finishes before B, it works fine. But if B finishes before A, it breaks. So there's a lot of concurrency and parallelism that gets introduced that makes it a harder mental model for certain use cases. So again, the whole point here being, if the earlier slides sounded great and you're thinking, I'm ready to take the plunge, I'm going to dive headfirst into the microservices pool, just remember there's a bottom there that you got to watch out for. All right. So what if there's just no way you can get microservices in place? The Sterling order management system is just not going anywhere, and there's nothing you can do about it. We just have too much invested in it. And that's a great question. It's a common use case. And fundamentally, there's nothing wrong with that being a requirement of your architecture, that there are certain monolithic legacy systems that you need to incorporate. What you want to do in that case, though, is kind of fake it until you make it. Wrap those in a kind of a wrapper or a container of sorts, and say, we're going to take the monolith and subdivide it into feature set functionality and try to, as best we can, abstract out wrappers or containers that will kind of abstract the fact and limit the coupling of how complicated it can be, and define all of that interaction of how do those different pieces talk and how pieces talk to that system. Define it with an API contract and make it all API driven. So get rid of your TIPCO integration or your Fusion integration or your file-based integration. Go to an API-driven integration and define your service contracts. The reference to Conway's law here is that the organization of people drives the organization of technical systems. So when you organize your technical systems that way, you'll often find that your teams, your 40-man team will become 4 distinct 10-man teams that actually work on different things. With the exception of actually doing the Big Bang deploy once every 2 weeks or whatever, they can stay mostly independent. So that's what the reference to Conway's law is. So you, while you're doing that, you try to decouple and isolate as best you can. And the microservices you would build are often the same wrappers that you end up building, because those make sense for a reason. They're well-defined domains. But every now and again, you'll get something that's coupled together because of the monolith, where you go, okay, this is the user/order service, which is a wrapper. And the reason why is because there was just no way with the monolith that we could decouple the intricacies of user and order. They were just so tightly coupled together, we just couldn't do it. The wrappers themselves should look just like microservices. They should be small code bases. They should be deployed to Lambda or deployed with containers. And that allows you to build in that backwards compatibility and feature flagging. And again, you're encompassing that and then negotiating your contracts there. So in a sense, you're making a monolith look like a microservices layer. And I think this slide illustrates it pretty well. On the left, you have your monolithic e-commerce application. And most of these e-commerce applications off the shelf have very low level, very powerful APIs. The cart APIs don't do things like compute taxes or do inventory checks. The product API doesn't aggregate different pieces of product information or doesn't tell you which attributes should or should not be shown or rank things based on SEO, or they're very, very raw, low-level APIs that you can write a wrapper around. So your cart service, microservices wrapper, can handle things like inventory check and tax. Your underlying e-commerce cart API built into the monolith is essentially the foundation that cart service wrapper relies upon. And that's where you got to give some of those monolithic platforms some credit. For most of the off-the-shelf ones usually have well thought out APIs that can do a lot of different things. They're not good at abstracting. So again, the example I'll go back to is your cart APIs typically are not going to do things like tax and inventory check off the shelf, but they will let you add something to a cart. And with those, you can build those wrappers. So if you look at it from a client perspective, to a client, it appears as though you have a series of microservices that is implementing your e-commerce application. And you can get all the benefits of the backwards compatibility and some of the benefits of the scaling, some. And then the services contracts being able to deploy whenever you want. So you can get pretty close to having a microservices architecture and the benefits thereof, even though under the hood you have a monolith, which is just a pretty powerful approach. So let's get into an actual specific implementation that used this approach. And this was for a pet specialty retailer. We implemented curbside pickup, which relied on some different pieces. So we'll just get right into the gory details. So you're going to see a combination of some third-party services. You're going to see some microservices wrappers, and by that I mean it's a monolith that was wrapped with a service to make it appear as though it's a microservice. Some true microservices, and then some AWS services. And the AWS services are great to call out because a lot of those you can treat just like a microservice. You turn it on, it's simple, it's got an instance name, you use it, it does what you need it to do, it scales really well. So in a sense, a lot of the AWS services are just free microservices you can turn on or off, and they work really well. The other thing I'll call out in this architecture is the microservices themselves are all on top of Lambda. And that not having to worry about scaling and containerization and dealing with the intricacies of Docker and images and image registry and all that, just throwing code up on Lambda and having all of that magically handled for you really lets you get this approach up and running quickly. So both the microservices in this architecture and the microservices wrappers in this architecture are all deployed on Lambda. So, you know, when you go to your enterprise and say, here's what we want to do, they say, well, how much infrastructure are you going to stand up and how much monitoring of this infrastructure you're going to need? The answer is not much, because Lambda handles a lot of this for us. Okay, so the use flow, the flow we're going to look at here, the use case we're going to look at here is user placing an order. So that involves firing up the mobile app, downloading the pictures and all that of the product, going through the security check and making sure they're a human being and not a bot, pulling some of the mobile specific details out of the database. So the e-commerce system, for instance, doesn't care what your device ID is, so it can send you a push notification, or doesn't care what your notification preferences are if you want to save those in the cloud, so they're synced between devices. So that's why there's a separate database specifically for the mobile app. But it will go to the e-commerce application and say, what does the product look like? What are the product details? And again, that was wrapped in that wrapper app. And then we'll go to the order management system, which in this case also handles inventory, and say what's the inventory status or inventory availability of this item, and combine that with getting the user's location from the third-party location service. We can get a pretty seamless order placement experience. So what you'd expect is they go to a PDP. It says, we have this in stock. It ships today. It would arrive at your door in 2 days. All those are critical. You have to have complete shipping visibility and transparency. It's available for pickup at your store, and here's the location of that store within X hours. That store closes at this time, and it's also available at other nearby locations. So that whole critical experience of, I want this user to buy it from us and not shop around, and so we're telling them we're ready to go. Maybe this is an impulse purchase, or maybe you just ran out of dog food, or what have you. We have it, and however you want it, we can get it to you quickly, and you could be picking it up an hour from now at this location. That's critically important. If you're not that transparent or not giving that level of detail, then you'll have a poor user experience. So that's one, and then that order is placed. So the next flow that happens is user gets a notification, says we're working on it, and then they get another notification says it's ready, come pick it up. So they'll open their phone, they'll see that notification, and we'll notice that they've seen that notification. We know that they have acknowledged the fact that we've told them. We'll then track their location. As they get closer to the store, we'll let the folks in the store know, hey, this person is 10 minutes out or 20 minutes out or whatever. Make sure that order's picked and ready to go. Or even they've arrived. They're in the parking lot, and they told us they're in a red Prius. Go look for that red Prius and bring them their order. And that's what you're seeing there with the webhook for the AWS Lambda is essentially the little spider web looking one is the mobile APIs in conjunction with the location service telling the in-store application to go notify the store partner or the store employee, this person's here. From there, the person receives or picks up their inventory or their product. And you want to, at that point, basically charge their card and decrement the inventory so that if someone else is on the way or someone else is going to place an order, you don't sell that same thing twice. And so you put a soft reservation on it when they place the order, and then you hard decrement your inventory once they go pick it up. And then you charge their credit card once they walk out the door. You can't, in some states, a lot of states actually, you can't actually charge the card until the person has, it's actually shipped or the person has the goods in their hands. So we fall under, in this architecture, that same constraint. So you can see here that the flow is mobile app to order service to charge that credit card and change that inventory. And then the push is actually from the store partner in the store app saying, hey, this person picked it up, I met them at the door, they're out the door now, so let's charge their card and decrement the inventory. So we got the architecture behind us, and I know that was a heck of a chart, but I hope what it illustrated is that would have been 3 different enterprise architect flows with a bunch of different coordination that would have had to happen. And essentially what we did when we built it was said, this service needs to have these 2 APIs, this service needs to have this 1 API, that service needs to have that 1 API. And each of the teams finished at different times. You didn't really care when they finished, and they were deployed into production as soon as they were ready. And then once it was all deployed, simply flip a switch on and it all just turned on and started working. It wasn't some coordinated, everybody deploy at the same time. So to kind of give you some insight into some user-facing things and some non-technical requirements, let me kind of go over some best practices of some things we ran into once we deployed it where we had to make some changes. So there's basically some learnings. One is make sure you can turn off curbside pickup in case of emergencies. The protests shut down some stores, and we were still showing that store as available for pickup and placing orders to that store, and someone shows up to pick something up and there's a protest outside the store. That's not good. So make sure you have the ability to pull some emergency levers and say this store is online or offline, or that's much more common use case, but less exciting to talk about is just the store is just slammed, or someone didn't show up. They just don't have the capacity to do curbside pickup that day, what have you. So that's another reason why that needs to be something you can turn on or off. A big one on the mobile app is if you're going to ask someone for location permission, make sure you tell them why. Knowing when someone is pulling into a parking lot, knowing that they're 10 minutes out, knowing that they're 20 minutes out, it's a big deal towards store efficiency. It makes the store employee happier. It makes them deliver better service. The overall customer experience is significantly enhanced. And one of the key drivers of that is getting that permission that says, we want to know what your location is. What we found, in hindsight, obviously it made sense, but if you just ask them for that and don't tell them why, they're not as likely to allow you to do that. If you tell them, here's exactly why you need it, I will only use your location when you're driving to a store to pick up an order, and that's only so I can have it ready for you at the curb, you get a lot more, significantly more people who will click, yes, I want to do this, and I will allow you to track this myself. It's pretty important to say, what are you going to build? What are you going to buy? What are you going to wrap with a microservices layer? There's a lot of things that already exist that are done really well. Some AWS services, push notification service, for instance, Firebase. No reason to rewrite those. They're easy to stand up. They're priced economically. The other example was the location tracking service. We originally thought, oh, I'll just build that. It's not too bad, right? You take someone's lat long, you measure how far away from the store they are, you assume they go 30 miles an hour, and then boom, you know how far out they are, right? And what we found out again, in perfect hindsight, was 10 miles away in downtown LA means a heck of a lot different time frame than 10 miles away in rural Georgia. So there's a lot of companies out there who do a very good job of solving that particular problem. And, you know, that's just an example. So there's no reason to build something like that yourself. This is more of a microservice best practice in general, but usually you're going to have an explosion of services, more services than you've had before. And in your traditional world, something goes wrong in the e-commerce system, you log into the e-commerce logging and pull up the log and see what happened. And when you have 7 times the amount of services, you go, well, we want to use the log aggregation service now. We don't want to have to pile into this thing's logs or that thing's logs or that thing's logs. So you start funneling and pumping all of your logs to a central log management system. And when you do, you're either creating a database that has correlatable PII. So in this microservice, I have their name, and that microservice, I have their address, and this microservice, I have some of their credit card details. Or you're shipping it to a third-party log aggregator, like AWS may do it, or Sumo Logic may do it. And so those have certain legal implications, like the California law, the privacy law, the forget me law, CCPA. Overseas, obviously, I forget what the name of the one in Europe is, but they have a pretty strict one as well. So keep that in mind. That it's a problem you'll have to solve. Take care of handling the persistent location permissions, and that is when you have the app open in iOS, which in the US I think is like 60% of the user base, surprisingly high amount of iOS users in the US versus the rest of the world, where it's more like 10 or 20%. They have the option to allow location while using the app or always allow. And you want to make sure they check that always allow, because only allow while using app is not very useful. They're not going to have the app open as they're driving down the road heading towards the store. And explain that to the user. Here's why we need it always on. And then make sure you have an alternative workflow. So maybe it's email driven. They get an email, it says come pick it up, and then click this link when you get to the store, or put up a big sign at the store that says here's a phone number. Call this number and tell them that you're at parking spot 7. So not every user is going to have a smartphone. Not every user is going to have a smartphone with your app installed on it, and not every user is going to remember to bring it with them. More often than not, maybe they leave it at home. So make sure it's a frustration-free experience if they don't have the technology. And what you'll find is that maybe 10 or 20% of your curbside pickups go through that alternative workflow. So if you're doing 100% call-in, that would be miserable. 10 or 20%, it's not that bad. You still get enough efficiency out of the automation. That's just overall, it's a smooth experience for all of your users. So some key takeaways, kind of overall. Use a microservices approach or a hybrid approach. You can get something like this out rather quickly. We got it out in 6 weeks. Probably could have been out faster. You know, knowing what we know now, we can probably do it faster for sure. But it's tough for old monolithic systems to get things done that quickly. Follow best practices, create smaller teams, and that will reduce your time to market. And this is as challenging a climate as I can ever remember in terms of requirements changing on a day-to-day basis. And you know, usually there's some uniformity, but there's so many rules and regulations just regarding how retail businesses operate now at a state and region level. Obviously, with the health concerns that this agility is more important than ever, I would say. A 3-month plan will not survive. And then last one, what we were all excited and here for. I know you guys are really ready to hear about the JBS sales pitch. So we have experience in implementing this hybrid approach. We've done it for a few of our larger customers, and we've done it well. So I'm proud of that. So hopefully you found some interesting information, and hopefully you're willing to listen to me talk about the JBS sub. As part of the webinar, we'd also like to announce that we're we're offering a quick launch lab. So if you'd like a free half-day assessment on what it would take to implement either curbside pickup or some other retail or e-commerce specific or even an education vertical, how can we apply these same principles and how can we learn these same lessons and do these same things well, we'd be happy to help you with that. And just reach out to us after the webinar today. So with that, thank you for attending. And Paige, do you want to handle some questions if we have them?
Yeah, I had a couple come through chat while you were talking, and one of them was, why did you choose AWS Lambda as a solution for the microservices?
Yeah, that's a good one. What's really cool about Lambda is you write your code, upload it to AWS, and you're done. They handle security vulnerability patching, provisioning networking, provisioning storage, scaling up and down, concurrency. They handle all of it. And it's not, you would expect when you hear that it would be terribly expensive. And the reality is the only way that I have found to where something is cheaper not on Lambda than on Lambda is when your utilization is a flat line. So if you have something that's computing the digits of pi, for instance, and you just never want it to stop, I wouldn't do that on Lambda because you're going to be paying for 100% of the time and it's going to be expensive. But the reality is most of these systems have spikes of traffic. They're heavier during the day and they're much lighter at night. They're really, really spiky when somebody sends out a promotional email. Hey, do a curbside pickup and get $10 off your order. The thundering herd of people coming to the system all at once comes in. And under a traditional infrastructure, you'd have to have that capacity stood up and paid for to be able to handle that. In Lambda, you just don't have to worry about any of it. It just works. For us, it's been a great unlock on how we can increase the complexity of an enterprise by deploying more things and yet still not have a ton of infrastructure overhead to do that.
Thanks, Joe. We had one more come in. Which third-party service did you use for geolocation?
We used Rakuten, and they handled the distance from store and users ETA and all of that for us. And they actually provide a SDK that we can embed into the mobile app to help with that too.
Very good. And lastly, we had one more. Did you have to make any changes to the monolith, or what changes did you make to incorporate that microservices layer?
There wasn't a whole lot. A lot of the low-level APIs that are referred to, like the add to cart APIs or the inventory management APIs or the order management APIs, essentially had all of the raw capability that we needed without having to do a ton of changes. There were some higher level abstractions that we had to write inside of the wrapper, but for the most part, the raw APIs did a great job. There were minor things like adding fields, but adding fields to those APIs and doing a deploy, we just said, just go do that one thing, do your monolith deploy, be done with it, and get that out of the way early.
Actually, we had one more come in. Is 6 weeks a standard implementation timeline, including discovery, implementation, and testing of the product?
Yeah, I think so. That or tighter. That's assuming you've got the team on the ground and they have the tools they need to support them. So you have an AWS account, for instance. You have the ability to deploy to it. You have your development team there ready to go. Yeah, then that's a perfectly reasonable, I think, perfectly reasonable time frame to do it, and if not faster. If you're early in this journey and you've never done microservices before, you don't have AWS or some easy way to do those deployments or stand up that infrastructure, then you're going to have more foundation laying that you have to do. But generally speaking, I think it's a pretty standard time frame.
All right, very good. Let's see if we have any more that came in here. Could you extend curbside pickup to accommodate delivery services like Postmates?
It's funny you say that. We have, yeah. The overlap of those functionality is very similar, and it required only minor changes, really. It was route the notifications to and from when it's out for delivery, and when it's delivered, and all of that to Postmates. It wasn't Postmates, but I'm not going to tell you who it was, because I don't think it's been released or announced yet. But yeah, no, there was a ton of overlap, and that's kind of I'm glad you asked that question, because those microservices were in place, and that functionality existed, and it wasn't built with Curbside necessarily as the primary benefit. It was each of these things has this feature that they released via API. It really was just a matter of gluing those existing APIs together.
Okay. I think that will do it. So I want to thank everybody for attending. And as we had mentioned in some of the emails that went out, we will send you a copy of the video on demand. And we look forward to seeing you again on our next webinar.